Okay, welcome everyone to Quality Improvement Methods. And today, inshallah, we'll continue with design for Six Sigma. We have stopped in the last recorded session at the measure phase, and today we'll continue all the remaining phases of the MADV. Today we'll cover a tool that is commonly used in the measure phase, whether you are working on the MADV framework or the DMAIC framework. Or even if you are not working on the Six Sigma methodology, it's a common business tools to import the best practice in the market from your competitors and improve your performance. We have seen the implementation of the benchmark when we have done the QFD and House of Quality. We have seen on the right side of the House of Quality that we implemented the benchmark for this technical design that you are planning to develop. Also, the benchmark can be done in different ways, in strategic benchmark or performance or process. It could be also product benchmark, which similar to the performance here when we compare to, or a process of manufacturing or process of service. The strategic benchmark, for example, that we have the strategic vision of 2030, and some of those strategic plans implemented in the vision, for example, investment in renewable energy, alternative energy sources. These are, if you think about it, it's somehow a benchmark and imported from other countries, like European countries who started this earlier. In investment in technology. This is also one of the things that many countries already started this long time ago, like China, US, and even in Japan. So this could be a benchmark when they started to see the best practices. So when they adopt this plan, they adopted also based on a best practice of strategic planning. If we are talking about performance, we could also refer to the QFD benchmark we have done for the drone. For the process, now in the process, you can refer always to whether competitors from your local or even outside who do the same process as yours, and see the amount of steps, the details and the description of the process, and compare yourself against them to learn and adapt, also to measure the outstanding practices in the process of the organization. An example I brought was from Malaysia education system for training and learning, and it's similar somehow to our environment as a student and instructor. So it is easily to understand how the benchmark work. The main thing that you have to develop is the criteria. Where are you measuring the best practice on? And then you put yourself here. This was Malaysia who has done that. And then you describe the best practice based on the reference or the resource. For example, here the best practice for the first one, the curriculum, let's say, in the education, the description of the current practice that they are working, emphasize on class-based learning. And this is typical. You can see it in education, whether in the primary school or in the undergrad or university colleges. The best practice was brought from Germany here, and they found that 70% practical learning and 30% theory-based learning. And the comments here, that is like an action plan or comments of recommendation to your current Ministry of Education or the responsible on that action for improvement. More hands-on learning, industry training offered as a part of the curriculum. So these comments are collected in the measure phase, and then in future phase, like in the analyze, and then if the design phase, then you can think about whether to implement them, whether to analyze them first and prioritize them. Then you select some of them. And the same for all the other criterions, they done the same. We can see here the employee skills, no structured training, so their employee, they were not trained enough. And the best practice they brought from Australia this time, the practical training and soft skills integrated in the curriculum to enhance the employability. And one of the things that attract me, and it's very maybe also here is beneficial to look at, is the government involvement. And when we talk here about the government involvement, the Malaysia practice is the Ministry of Education, MOE, develops the curriculum. Whether now the MOE itself or the responsible under the Ministry of Education, like universities, schools, or whoever. Now, if we talk about regular schools like high school, primary school, this is done also in the Ministry of Education. In universities, somehow, the universities themselves, they do their own curriculum. But see, the best practice here was brought this time from Japan, and they see a collaboration between ministries, industries, and academia. All those three are stakeholders in developing the curriculum. And this is takes us to the point that even the Ministry of Labor here, as you can see, a collaboration between Ministry of Education and Ministry of Labor to develop the curriculum is when students graduate from high school or even from universities where you're going to apply this. The Ministry of Labor, they will be involved in developing the skills needed for the market. So no more that the Ministry of Labor will say that the graduates are not qualified for the market needs, or they are not fit for the market needs, because actually they were working in developing the curriculum. So they should have known from the beginning what the set of skills or knowledge needed from the graduates. So they have to include it from the beginning in the curriculums, along with the academician, who also they have to be there as a subject of expertise in the fields, along with the ministry and industries. The industries are the people at the end who will hire those graduates, so they need their involvement in building the curriculum. And this is really good if you think about it, how curriculum could be look like when a practice like that is happening. So they implemented all these criterions, and they look for the best practice and the resource for the best practice. And this is in a very high scale, but when you do like in a process or a product, you will work in a smaller scale, but you have to identify the criteria. Where are you benchmarking, and your current practice and the best practice, and where you got this practice from, best practice, where did you get it, and the comments for your current practice. This is, you do it in the measure phase, and then you take it further in the next phases to analyze them and see the prioritizing. You see also the resources you have available, whether you can implement all these suggestions or no. So this was the benchmarking example and tool. We move on now on the third phase of the DMAID-V, the analyze phase. And we have seen the analyze phase in the DMAID before, but here it's different. And even the tool that we are going to introduce today, it's a whole total spectrum of implementation. You can do it whether in DMAID-V. Actually, this method that we're going to introduce today, you can implement it as a quality improvement method stand alone. You don't have to involve it even with the Six Sigma. TREZ is a Russian methodology for improvement, and those acronym, this acronym, the TREZ, stands for Russian verbs or names, but the translation of TREZ in English is theory of inventive problem solving. This is the translation for the Russian name of TREZ. It's a problem solving. It's you can hear I highlight for this word, it's inventive. So it needs creativity, and as an engineer you are good in this, so that's why this method fits engineers to solve problems. It's a systematic methodology, so you know where you start and where you end, and the methodology fosters invention for project teams who have become stuck in solving a problem. What it does, it provides data on similar past projects, and this is the good thing. It's based on experience before, and you learn from previous experimentation and solving problems, and then you can adopt these solutions to your current problem and solve it and move on in the challenge. TRIZ is based on two basic principles. Those two principles here. The first one says somebody, sometime, somewhere has already solved your problem. And this is really something that when you struggle and you find there is no solution for your problem, this is very good and optimistic statement. Is somebody, sometime, somewhere has already done and solved this problem and or similar to it. And this is the thing, is it doesn't have to be exactly, but at least similar to it, where you can use that solution and using your creativity, finding this solution and adopt it to your current problem. And the second principle, it says don't accept contradictions, resolve them. Contradictions متضادات, يعني don't accept that. When it says I have to utilize my resources and then I don't have the contradiction, it says that you don't have money to utilize your resources, then you either increase the resources, whether money or whatever resources, or you utilize the resources without referring to that obstacle, if it's money or time or labor. So you don't keep the contradiction. So you have to move on by eliminating one and focusing on the other. Now, how the systematic methodology works. Start from this point here. Your specific problem. Your problem is specific on a queue line in your shop, or in your restaurant, or in the market, in the supermarket, or it could be let's say the utilization of your resources was not high enough. The variability of your production is high. This is this is your problem, okay? Your specific problem. When you use TRIZ database, you transform this specific problem into a general problem. So when we were talking about your restaurant, let's say queue line, or you are let's say producing cars, and then there is a variability in the production or failure of your product, then you have to transform this after you reading in the database, which we will cover it soon. How is the database is systematic also when you look at it in TRIZ. You transform your problem into a general problem. And then after you transform it, again, you will look to the database of TRIZ, and then you will find a general solution fits the general problem that transformed from your specific problem. After you find the general solution, then here it needs your creativity, and it says here in this principle, adapting this solution by using your creativity to transform this general solution into specific solution that solve your specific problem. We will see an example before we go to the example. Let's just demonstrate what is the database I was referring to when I said TRIZ database. The TRIZ database is contained of 40 principles. Those principles, with all information related, are in the shared folder on the aid module. You can find them. Here are the list of all the 40 principles, and due to the time, I'm not going to cover all of them, because those are, when we come here to the systematic methodology steps, it's the general solution. We are talking here about 40 general solutions. And then it doesn't mean that when you know it, it's exactly you are going to implement it to solve your problem. It needs, as we said, innovative and creativity. So going over them in details, it will not mean that it will solve any problem you face. That you have to look at them when you have struggle in a problem and read them and find the one, as we said, you have to extract your problem from a specific and transform it to general. And then you can look to the 40 principles here in this step, so you can find the general solution fit your problem. And that can come by looking to the definitions of each of those 40 principles. And then you find maybe more than one. It doesn't have to be one. You could find more than one. Those 40 can fit a wide range of problems. They develop this sheet to refer as a symbols for all these 40 principles, and they write the name of each principle. For example, let's say just taking the first one here, it says the first principle, segmentation. segmentation يعني التصنيف أو عمل categories أو جعلهم يعني في أصناف مختلفة أو categories مختلفة. And you see how is the figure referring to segments. So you have different segments. And if you recall, this was something that we already have covered before when we talked in the Six Sigma DMake. We talked about the Pareto analysis and Pareto chart. If you think about it, Pareto, it does really use segmenting or segmentation. It segments the causes of the problem and let you know or tell you that you have to focus on the 20% that will solve 80% of the effect. So this is a segmentation, but doesn't mean that Pareto is the only tool or the only way to use or adopt the segmentation principle of threads. You can use also, let's say, cause and effect. Cause and effect, another segmentation. It does segment the causes and put them in categories. As we have covered earlier, it shows you material, manpower, machines, measurements, Mother Nature or the environment. All these are segments of the causes of your problem. And again, Pareto or cause and effect, they are not the only tools in the world that based on the segmentation concept. So segmentation is a general solution. It could fit a general problem, but then you have to use your creativity to adopt it as a concept into your specific problem by providing a specific solution. So moving to the 40 principles, you see this chart where people can print them and have them next to their wall or in the workshop. So they look at them all the time, so they can always educate themselves about solving problems when they face it in the work floor or in the manufacturing or in the service industry. These symbols just to identify the name, for example, segmentation, but doesn't mean you have to do this shape to solve it, for example, or something, but this is just a symbol. So these 40, all of them are already covered in or available on the shared folder, and you can access them and see examples for each of those 40. I will go randomly on some of them just to give you an idea how they are widely can be implemented and in different ways. Let's start here. It says principle 2. So principle 2 here from the list. It says taking out, and this was the simple. It looks like that you are taking this red one out of the pieces, and when you will look to the taking out then definition, it's very general, as we said. This is something that you can implement taking out in a process. Let's say you have a process. Let's say you have a set of steps in the process. You evaluate those steps based on these 4 criterions. The first one, essential or non-essential step. Value added or non-value added step. Okay? Essential means it's important. Value added is adding value to them at the end, which is the objective of the product or the service transaction or the customer requirements. Okay? sometimes you can refer to something that it's important, but the step the way how you do it is not adding value. It's actually wasting time. For example, waiting to issue, for example, a driver license. If you were waiting in the office where they issue the driving license, it's essential because otherwise you will not. But does it add value? No. So then here how we think to things and distinguish between them. So if the step or if the process or even the product or the component, if you in your device you are going to add, is it value added? For example, you are using a PC for your home and you're not doing like much of heavy applications or gaming. So adding too much of giga RAMs that maybe is not adding value to your objective use of your PC. Okay, it's essential to the computer. Yes, we understand that, but is not adding value to your objective. So here, there's just you have to distinguish whether something that is essential as an important, or it's at the same time if it's value added. So if it's both value added and essential, then you work on this and you have to consider it as a primary objective for you when you use it as a working evolution on that one. If it's essential and none added value, then here you have to improve and analyze and find what's happening here. Okay, it's non-value added, analyze it, then how we can utilize it, how we can improve it, and how we can reduce it if there was waste of non-added value, how we can combine, if you recall, the steps of the Formula One, how they do the pit stop and how they move the SMED tool that we have covered earlier in the lean, to use the pit stop in short time while the car is off the race. If non-essential and value added, the same, you have to analyze and improve. But if it's non-essential and non-value added, then you eliminate. And here is the concept of the taking out comes. It's general concept and general principle, and it could be general solution. But when you adopt it your problem to specific problem, you can, for example, use such tool or any other tools with the same general concept and start eliminating the non-value added and non-essential steps or process or components or whatever. Principle 3 says that local quality. And here local quality, this is something I intentionally use this tool because we have used it in the previous session, which is house of quality. House of quality is representing the local quality. You want to see how you evaluate your current quality and how you develop your product based on your customer requirements versus the design requirements. At the same time, you also benchmark with your competitors and evaluate the local quality in your industry. So you do the competitive assessment, as we explained earlier, how we do that, and you do the house of quality to implement the concept of local quality. Principle 4, and let's go back to the dash or the symbols here. For 3 was a local quality here, and they refer to that with this knife, and here asymmetry, and that's because symmetry tanavur or tamathul, and here asymmetry, that's mean is not symmetrical, and you see maybe the shape that they are using is for a hair that is not symmetrical in the both sides. This is just a sample to recall the name without looking to the term itself. And what is this concept? Or this is an output of or a result of implementing Trez and using or developing or designing mouse for the keyboards. Mouse in the most common application use symmetrical. But when they use the asymmetry, which is the opposite of the symmetry, اللي هو عدم التناظر, they come up with this mouse with a concept of not using symmetrical concept, which is using the principle for that is the opposite of the symmetrical, in a way that gives more ergonomic design for the mouse use, because here the trackball here, the red one here, you use it to move the pointer. As I'm moving now the pointer here, you use this trackball instead of moving the whole mouse right and left. So you just move the trackball here by your finger, and the pointer will move, and all the clicks will come on this side. So your hand and your palm or your wrist, it will be more comfortable in this position without moving your hand back and forth or forward and backward, which will be by the time or using it for a long time and consistent, maybe affect your wrist and shows you some pain in your wrist. This has come from the concept or the principle for when those people, they wanted to develop a new product that is has a creativity also at the same time innovative compared to the existing one. Well, this works for the right-hand people. If someone like me, left-hand, then they have to design it on the other way and have the ball on this side and those buttons on the other side. But anyway, this is innovative solution for the right-hand people to have more comfortable and more ergonomic product and innovative product. Moving on with the principles. Principle 19, which is the periodic action, and you go here in the chart and you see 19, it says periodic action and shows you a figure or symbol refer to that one. Periodic action, it can also go in a wide range of tools and applications where you can implement the concept of periodic action. PDCA that we have covered previously in the Six Sigma is a common concept or tool to be used for the periodic action, and any others that with the same concept it could fit. If you think about it, sometimes even I face this when my students in a capstone project, they face a struggle or they face a problem and they struggle in a point to solve their capstone problem. We refer, and sometimes I do that even with them, I refer to previous projects where we come to the same or similar point, even though those two projects are different in terms of the case or the nature of each one of them. But I refer to something similar and I ask them to do or adopt this in their current status. So you do it somehow based on your previous experience with projects and solving, and it comes and it develop this principle as you have more experience. You will have them maybe in your mind without notifying or knowing that it's a principles and it's already there somehow in the TREZ. Principle 25 says self-service, and the service here was, as we see, the inspection. And instead of having auditor to inspect, you do the self-service or the self-inspection as a specific solution from the general solution, which was the self-service, to do the inspection. And instead of having inspector, and that will cost you. We have seen also this before when we did mistake proofing. If you have a system that automatically monitor and detect, that will be applying the principle 25 of self-service. And you see the symbol here of 25. Let's go to 25. Yeah, here, self-service, and they put this shopping cart here. And that's mean you are self-serving when you do the supermarket or you do shopping. Principle 32, color changes. And this could solve many of the problems that need categorizing again, or identification in visuals, like for example using different colors for the tools or the files that you are always or often use them based on the segment. You see that even in the government cars, like the police cars, they have black and white color. The civil defense, they have different color. Also in the hazards material, they use different colors, so you can identify the type of hazard by just looking to the color label. And here, when we refer to the color changes, even here they put the traffic light, so easily by looking to the color, you can identify the traffic signal or the traffic light signal. Okay, moving now, an example. I brought this example to show you in details how they use one of those tools and think about it step by step, and use this principle of trace to solve the problem. They use here, or an example brought for implementing principle 19, which is the periodic action. Okay, the problem description says a cafe serves a great coffee, but queues are long during lunchtime. People come for the brunch and then, or they eat and then take coffee. After the 2 p.m., it gets more quiet here in the coffee or in the cafe. The cafe is also a mini hub for nearby startup companies. They use the Wi-Fi in this cafe for their meetings during the time after 2 p.m. The cafe needs to manage the capacity in a way to fulfill its range of customers, meaning that if you look to, this is just not the exact cafe, but to refer how it looks like before 2 p.m. Those are the queue for the cafe, and after 2 p.m. it gets very slow, and rarely they have people in the cafe. So they want to manage this capacity in a way to fulfill this range, especially after 2 p.m. It's a quiet, long time, and if you don't have enough customers, you will be just only relying on the people that comes before. Now, this is a problem, and it's very specific to this cafe or restaurants, you can say, or lounge. But when you use the trace principle, you look all to the all 40 principles, and you see which one could, by reading the definition of that one, could solve your problem and transfer it or transform it from a general solution into a specific solution, serve this problem exactly. Okay, so these are the given information that we got for this cafe. How we implemented the periodic action principle. The periodic action principle says the use of periodic action instead of continuous vibration. Okay, it's very general again, and here is the creativity where it needs to be implemented as an engineer. If you just read it, you may not think, okay, what I'm going to do here if I'm going to implement this principle. Yes, but from the creativity and the previous and experience you do in work, you think about it in different spectrum and different direction, how to solve this specific problem. The continuous vibration here, it's very general, but when you make it specific to this case, the vibration is the variability of the range of customers. We could refer it here, and we found where is the link. Fulfilling the range of customers was the variability comes or happens in this cafe. So they want to use a periodic action steps to solve, or instead of having this continuous variability. It's common, as we said, to use a PDCA, and just to refer to it here as a referring, this is a sample or a tool that used as a periodic action, but doesn't mean, and we will see here, doesn't mean that it will be the solution. The PDCA was not used here to solve this problem, but the principle was used. So all the tools, you will see them in definitions. This is just an example, as well, and I was giving you an examples for Pareto and cause and effect diagram as for the principle 1 and 2. But here it doesn't mean that you have to use PDCA. It just says that it's an example of this periodic action tool. So what they did exactly, they the solution after they adopted and used their creativity, they come up with this idea. They have offered 3 hours of a coffee refill during the time where is the cafe is quiet and not busy, and that will moving the demand in the quiet period. So after lunch and after lunch, so the attracting those people in the neighborhood who has a startup business. So they have their meetings in this cafe, and also they can stay for longer time, and they may also order snacks and food because they will offer them a free refill coffee. The same for other people who come in the early time before 2 p.m. This will attract them to come again if they need a cup of coffee or a snack to this place, because he offers something that attracts people compared to others. Maybe cafe, they don't have this offer in the area. So this is using the periodic action concept to utilize, or maybe to reduce, in our case, the variability of the or manage also the range of customers in your cafe here in this example. So moving from the analyze into the design phase, and also in the design phase today we'll introduce a new tool that, as we said, any tool in the make or the made v can be used on the other framework based on your needs. Even Trez, as we said, it's a methodology itself. It was not developed from the Six Sigma at the beginning, but this is the unique thing about the Six Sigma methodology. It can carry any methods or techniques or tools can fulfill or achieve your project objectives at the end. And that's why it is commonly and widely implemented in solving problems. Tools for design, we will cover today a new tool called the Pew Matrix, and it's an analysis tool that used to refine a list of ideas you have by using a matrix based on a weights. So you use weights for those ideas or criterions, and compare the conceptual design. This matrix used for decision making. It helps you to make the decision, and it helps to select the best solution or the most feasible solution or option you have among alternatives. You can use this tool also in your capstone project to compare alternatives and see against each other or against the current status. Creating the Pew Matrix needs these steps, starting with creating a chart of criterions in y-axis versus the concept, which is the x-axis. And step 2, pick one concept and rate it across all the criterions. And step 3, fill out the rest of the chart with the same. And instead of same, you can use 0, plus or minus, depends on how you evaluate this concept and the criteria against that criteria. If it's the same to the current process or to the current machine you are using or to a certain system that you are using, then you put same or 0. If it's better, then you put plus. If it is less, then you put minus. And we will see in the example. This done relative to the one entered data and the step 4, we do sum the pluses and minus and also the same or zeros if you used, and you integrate or iterate all the steps and then find the best one and evaluate the result. Let's see an example here. We have 4 alternative solutions, let's say, or companies or devices or products. As we will see here in the example, you can apply A, B, C, D, or those alternatives to improve the current system that they have. And the manager wants to know if one of these 4 systems would be an improvement over the current system. And the manager asks you to use Pew matrix to evaluate the alternatives. So you decide the criteria for the selection of alternatives, then you pick the 4 most important out of these. For example, the criterions you use as the most important to be evaluated is the price, hours of work, speed, and reliability. And this can be done using a brainstorming session to evaluate, or use all the analysis tools that you have learned before, or the measure tools to identify what criterions are the most important, or maybe you list them all if you want. And you put all the alternatives here on the horizontal line, and you start assessing each alternative against the criteria, comparing to the baseline. Now, whether you compare it to the baseline, you compare it with another product, this is depending on your case and the design. And for this example here, they were comparing against the current system, and they have now multiple systems or alternatives. They could replace it with their current one, and they would like to evaluate those alternatives compared to the one they have now. So the baseline, we put zeros here as the baseline that where are you referring to, and you compare, let's say, alternative A and the price, and alternative A with the hours of work in terms of the hours of work. Let's see here in the next slide. Here it shows how we do that. For example, here, alternative A, when they compare it in the price with the baseline, it was plus. When it says plus and its price, that means it's cheaper. Don't get it wrong. It doesn't mean that it's more expensive. In price, you always look for the savings. You don't look for increasing the price. So when it says plus, that means it's cheaper compared to the existing system. And when it says, when they compare alternative A with the hours of work, they found is the same. So the hours of work for the current system and this alternative, they are the same. When they compare the A, alternative A, with the speed, they found it has more speed. So that means processing time is lower. So they give a plus here to this alternative. And in terms of the reliability, okay, here they found, okay, it could be high-speed engine, but it's turbo engine, so the reliability it will be lower compared to the natural aspirated engines in the cars. This is just an example to show you how things goes. So you just evaluate it here with minus, since this alternative has a lower reliability compared to the existing system. You do the same for all the remaining alternatives, and then you add them up in terms of plus, minus, or zeros. So you add all these pluses here. How many plus we have? 1, 2 for alternative A, so you put 2 here. How many minus we have? We have 1, so you put 1 here. How many zeros we have? We have 1 0 for alternative A. You do the same for all of them. For example, here in C, we have 3 zeros. That's why we have 3 in the sum of 0. We have 1 for the plus, so we put 1 in the sum of the plus. For the sum of the minus, we put 0 because we didn't have any minus here. You do the same for all alternatives, and then you evaluate the results based on the highest pluses, and you see which one has the highest pluses. For example, here the D has the highest pluses, so we select D. Also, you may find them that they don't have pluses, advantages compared to your current system, so you may rethink about changing your system, since it didn't show that any of the alternatives shows any better than your current system. and also the minus to compare among them if they are very close to each other and you have many criterions. So then you can take it to another tool in the analyze to also analyze these designs and see which one is more has more priority compared to the others, if you are going to decide to. But here in general, you will find which one has the highest sum of pluses compared to your system or your baseline, so you select that alternative. Moving to the last tool on the last phase we have in the domain V, which is the verify phase. The verify phase, we have response planning, and the response planning is similar or is an added step to the control plan that you usually do in the control phase of the make. In the verify phase, you can use a set of tools. You can use even simulation to verify your design and put your system or your device characteristics into a simulation program that can run it for a long time and see how the results goes. Could be a verify. But here we just are going to present one of a new tool also. Response planning sets what to do if process doesn't meet the quality requirements. So if I am not meeting the requirements or I'm not meeting the specification, well, then what should I do? Developing responsing plan, it needs these steps: designate person responsible for addressing the problem and the requirement, and those needed always the specialists who know the technical details about the problem could appear in the process or the device or the machines. Specify initial steps to take, and then based on those initial steps, provide guidance what to do in the common scenarios. Give at least a general plan if none of those scenarios appear, so what you exactly to do if none of the scenarios you have listed appears. Test it in real time and adjust the plan as it needed. So here is an example of the response planning. It came up from manufacturing industry. A company that makes fixing for the building industry has developed a new line of screws made from a tougher blend of steel. يعني عملوا نوع من انواع المسامير هذه بنوع معادن جديد واقوى المفترض يكون. There are 5 points in the manufacturing process where the malfunction or the errors could cause size of variation. فعندنا 5 steps or phases. عندنا 5 مناطق يتصنع فيها هذا المسمار او 5 مراحل where the variation ممكن يطلع من اي واحده من هذول. And those phases, they record them before it begins. Yes, and the wrong wire, they call it the neck width. So this is the phase 1. The cutting machine, and they call that, or refer it to the length. The head stamper, or the head width. The 4th one is the shaping, or the point width, they call it. And the threading, or the thread cutting, اللي هي بتعمل هذه الخطوط اللي تشوفوها هنا، هذه threading. Thread length, الطول حقتها ومسافتها أو قياسها. Based on the given information, this was the control plan, not the response plan. Pay attention. The control plan shows the tolerance and the specification, okay? But didn't show what to do if something goes wrong in the specification. So they listed all these 5 phases, and the gauge, الجيج اللي هو الأداة اللي هتستخدمها للقياس, okay? And the specification for each one of those, like for example, the neck or the head or the length, the specification is 2.5 inches for the length. This is the thread length, sorry, the thread length اللي هو الخطوط هذه, not the whole length of the screw, okay? 3 inches for the length and 2.5 for the thread length. The width is 0.35 and so on. These are technical specification. Anyway, it could maybe not the same dimension can applicable to these shapes, but I brought this picture to show you how it looked like. The tolerance for each of those specifications is 5% from this dimension, and the frequency is 5 per hour, 5, let's say, samples you are taking per hour, and the tool you are going to use to demonstrate these readings is the X-bar chart. This is the tool for measuring these specifications in inches, اللي هو laser. But the chart here is a tool for representing these samples or the data. And the name of that tool is the Phillips head screws, this one. This was the control plan they developed. So what is the response plan different than the control plan? In the response plan, you develop a set of actions in case of any of those specifications we have mentioned here went away from the tolerance. So if, let's say, the length is exceeding or exceeding the control limits, whether the upper or the lower, what set of actions you should do as an operator or as someone is working on the process line. So you start with check most recent settings on cutting machine, run diagnostic on cutting machine. If diagnostic it's all clear, send a wire sample to the quality auditor QA for a pull test. If clear, escalated to the quality auditor team leader. Remember, when we talked about the steps of the response planning, we said here you have to provide a guidance. At the same time, you have to put a general plan if none of those scenarios apply. And this is what they did. If none of those scenarios, checking and running the diagnostic and even doing this, the wire sample test or pull test was enough to resolve the issue of exceeding the control limits here in terms of this characteristic, then you do this step, which was that what it says. Then you have to tell the labor or the person he's working, the technician, what he has to do in that case. It doesn't mean if he couldn't find any of those fix the problem, then he just stopped there. Then the last step should always, as you see in all the characteristics, the last step, you escalate it to the supervisor, or as it says here in the example, the quality auditor team leader, to tell him that, okay, I tried these as it shows in the response plan, and it didn't resolve the problem. So he has to interfere now the process and see what's going on. Maybe after trials, they found things are not listed here, and they have to list it as one of the set actions to resolve the length issue if it appears. So the response planning, you identify already the tolerance in the control plan, and you check, or you put all the check needs, all the steps needed. For example, here in this case, they put check the machine or the material. If the machine is working correct, then check the quality of the material provided, whether the material from the raw material, like comes before this process happens, or the raw material between the steps, because this one here maybe is handing to this one, or if all of them work not in series, or they are not depending on each other, so you refer to the raw material comes from the supplier, or the raw material between the steps, maybe if they are working in series. So you check the material comes from the previous step to make sure whether it was a material issue from the previous step or not. So it was specifically designed for this case and this example. But as you can see here, the main thing is you have to tell the operator or the person is working on the line, even if you think about it in some manuals comes for equipment, or even if for your cars, it says try to troubleshoot the problem yourself at the beginning by doing these steps. Try to hold this button here for a certain seconds or minutes. Try to reset this, or try to unplug the battery, leave it for a minute, then put it again. All these instructions as a representation of response planning when something happened that exceeding the specification of the operation or the product. But always you have to mention this step where if none of those actions were working and fixing the issue, what should I do? So usually it tells you, even in the manual, if didn't work, then you have to take it to the authorized dealer to diagnose it, or to the workshop, or to the return it to the provider. So you have to give a step or action if all the listed steps that the common scenarios could happen didn't work. So that's why you see the last step here to escalate it to the quality auditor team leader, where he has to see what is the problem is. And always you have to review this response plan and update it as it needed. This was all for the Made V design for Six Sigma. We introduced new tools compared to the one we have covered in the DMake. I hope you enjoyed the session and you learned from these tools, and I will see you in the next sessions and with a different topic.